Welcome everybody, Anthony Sequeira here with Stormwind.com, and great to see all of our audience members here on time, ready and raring to go in the live class for ICND1. We are in session number 7, and we want to pick right up, of course, with a look at subnetting. Yeah, we said we wanted to elaborate on subnetting in this particular class session. So we are really going to go through the paces on this topic of TCP/IP subnetting. Now, let me just make sure I bring us right back to where we are in the material. One moment here. Want to make sure we don't skip anything and figure out right where we were last class. Just one moment. All right, if you recall, in the last class session, we were looking at none other than the subnet mask. Do you remember this? And we said the subnet mask is, speaking of mask, I got to correct my mask here. I'll do that at the break. I seem to be disappearing on us. But we said that the subnet mask is indeed a value that is going to dictate which portion of the address works as the street name and which portion of the address works as a particular house on that street. Remember that breakdown? The subnet mask dictates that. Now look at how a subnet mask works. The bits have to be turned on contiguously. Yeah, look at that. So you can have all of the bits off, not shown in this illustration, but you could have all of the bits off, and that would, of course, produce a subnet mask value of 0 in a field, right? Or you can have the first bit on, or the first 2 bits on, or the first 3 bits on, or the first 4 bits on, etc., and that would create the following decimal values in the subnet mask. So subnet masks are interesting, right? And that they're going to have a very fixed number of values they could have in decimal. Either 0 or 128 or 192 or 224 or 240. Okay, so the subnet mask, those bits have to be turned on or off in order. We say contiguously in the subnet mask. Now, you remember from our review of IP addressing that a Class A address has the first portion of the address identifying networks and the last portion of the address identifying hosts in those networks, right? Yeah, you remember us covering that. You remember us covering that information very early on. Now, that is going to make for a default subnet mask of all ones in the first octet. Yeah, so what do we have for a default mask for a Class A? Well, we have 255, 0, 0, 0. Makes sense, right? Yeah, of course. We are going to have first portion of the IP address identifies the network, and this last portion, in fact, let me use 2 different colors. The first portion identifies a network, and the last portion, 3 octets, identify a host on that network. So your mask is right there. And of course, we like to write that in dotted decimal form. So your mask is 255.0.0.0. Make sense, everyone? Now, there's a cooler way to write it, and that's prefix length. I love this. So you say, what's my IP address? Oh, it's 10.1.1.100, let's say. And then you say /8. Oh, that's pretty neat. Instead of writing out 255.0.0.0, you just indicate how many bits are turned on in the wildcard mask. All right, any questions about this Class A? Any questions about this Class A? All right, great. I didn't think there would be. This is kind of review. The only thing we didn't look at before was the default subnet mask, but it makes perfect sense because we said earlier in the course that this first octet in a Class A would identify your network. Now look at a Class B. In a Class B example, we have a subnet mask of 255.255.0.0. And sure enough, this means, as we already knew, that the first two octets are going to identify the network, and these last two would identify hosts on that network. If you want to write it the fancy way, the kind of shorthand way, you can say /16 for the subnet mask. And then we have a Class C address. With a Class C address, sure enough, the default subnet mask is 255.255.255.0. And if we were to write it in shorthand, it would be /24. The first three octets identify the network, and the last one octet identifies a particular host on that network. Now, mathematically, it works out that the more bits you use to identify the network, the fewer hosts you can have on that network. What is the formula? Well, to figure out how many networks you can create, you do 2 raised to the n power, where n stands for network bits, and that's how many networks you can create. Okay, 2 raised to the n power. To see how many hosts you can have on one of those networks, I do 2 raised to the h, and then you have to subtract 2 from that, and that is your hosts. Why do we subtract 2? Because we can't have a host address that is all zeros, and we can't have one that is all ones. And we talked about that earlier in the course as well. One identified the network itself, the other identified a broadcast. So, let's look at some examples here. In a subnetting situation, what we do is we borrow bits from the network portion, and you can see this is a Class C example. we borrow bits from the network portion to identify additional networks. If we borrow bits to identify additional networks, how many additional networks can we define, and how many hosts can each of these networks have? Okay, let's say I borrow 2 bits out of this portion that was identifying hosts before. How many additional networks can I define? 2 raised to the 2 bits we borrowed, and we can consult our conversion chart, and we remember that 2 raised to the 2 is 4. So we can create 4 additional networks if we borrow 2 bits for subnetting. How many hosts can we have per network? Well, we borrowed 2 bits, so that means there's 6 bits left for host addressing. 2 raised to the 6th minus 2 is equal to 62. And again, we can use our handy-dandy conversion chart that we created in class together yesterday to quickly arrive at the 2 to the 6th value. So, if we borrow 2 bits for subnetting, we can create 4 more networks, and each of those 4 networks can have 62 hosts in them. Isn't this cool? By the way, we stick to Class C examples in here because we're dealing with real small networks in CCENT. But think about it, you could do this in a Class B environment. In a Class B environment, you have 16 bits. You could borrow like 13 bits. How many networks can you create? 8,192 new networks. Unfortunately, each network can only have 6 hosts inside it, but you get the idea. How about a Class A? Well, in a Class A, it gets more exaggerated. You have 24 bits to borrow from to create subnetworks. You could borrow 21 of these bits, and that would create over 2 million subnetworks, each which could have 6 hosts. Amazing. But again, we are concerned with Class C examples because a Class C is representative of what we would find in a small network infrastructure. And they also don't want you to have to do any of this gory math, right? So, before we get too ahead of ourselves here in the math of subnetting, let's do some review of, kind of what we would even list on our scratch paper. Remember, on our scratch paper in the exam, I do this. Right? Let me redo that so you can see the whole thing. Hold on. All right, I need to start right here. There we go. And notice how quickly I can get this built. 1, 2, 4, 8, 16, 32, 64, 128. And remember now, we've got a couple of formulas. 2 raised to the n equals the subnets that we can create. And 2 raised to the h minus 2 is equal to the number of hosts we can have. And it's fine if you write all that on your scratch paper. All right. Now, everybody got that. And we all know how we can use these particular facts, right? Now, before we get any deeper, I got to tell you, one of the things that I'm really passionate about here is making sure that none of you start doing this subnetting and you're doing it great, but you really don't know why it is what you're doing and how you're doing what you're doing. You know how to do it, but you don't really understand the why of it. Yeah, like Brandon says, how would we use this in the real world? Exactly. So before we get too deep in the mathematics of it, let me back up a moment here and let me go over with you the real world implications here. So in the real world, let's say you have the RFC 1918 address 192.168.1.100. And of course, that's a default /24. In other words, the subnet mask is 255.255.255.0. And you want to install a router in your house. Yeah, you want to install a router in your house. And you want a connection upstairs to switch 1 where you've got a bunch of devices. And then downstairs on switch 2, you want to connect a bunch of devices. So what you want to do is you want to break this up into 2 networks. We actually call these subnetworks. So you want to extend the subnet mask, what we call borrowing bits, to create network A over here and network B over here. You see? That's how this works. You want to take a network address that you have and you want to break it up into different sub-networks. Pretty cool, huh? Pretty cool. Okay. Now, by the way, from the math of it, how many bits do you need to borrow to create 2 networks? Well, if you borrowed 1 bit, 2 raised to the 1 equals the number of networks you could create, and that would be 2. So we only have to borrow 1 bit in order to create these 2 different networks. Pretty cool. What would our new subnet mask be? 255.255.255.128. That would be our new subnet mask with the 1 bit. And Tim says, why do they call it borrowing bits? Well, that's just the term that commonly gets used. You might hear people say stealing bits Because after all, we really don't plan on giving them back, do we? When you borrow something, there's some implication that you'll give it back. We're not giving it back here. We're stealing it. So you'll often hear it as stealing bits from the host portion to create additional subnetworks. Pretty funny. Well, what's the process? All right, so you look at your address. Okay, you look at your address and you say, all right, what do I have for an address? Daniel, I'm gonna hold that question. Don't jump too far ahead. Okay, just hold on. You're gonna see how all of this works. Don't try and jump too far ahead by going any farther than what we've done. Okay? So in that last illustration, I'm showing you why we subnet. That's all I want to do right now. Why we subnet. Okay? Trust me. Just I know like everyone wants to go ahead here and it's real tempting and you want to just get this done, but this is we're going to have to go slow and carefully. And by the way, this is a video that you're probably going to watch a bunch of times. Yeah, students report that the last video we did together and this video we're doing today, they report that these are videos they watch a bunch of times because it typically takes a bunch of times to get it and it takes a bunch of practice. Okay, well, Daniel, let's back up. Are you clear on why we subnetted to create these two networks, A and B? Forget the math of it. Okay, good. Then you're all set. Then you're clear on what I need you to be clear at this point. All I really wanted to do with this illustration was show you that we take an address and we subnet it to create, in this case, two different networks. All right. Now, we'll get into the math of it. But let's talk about the overall process. Like, what does Cisco recommend for the overall process? Well, obviously, they say take a look at your IP address and then figure out how many subnets that you require. In this case, you are going to shoot for additional subnets, right? I mean, you want to kind of give yourself a few extra if you can, because that would avoid you having to renumber your infrastructure when it grows. So then, based on the requirements of your organization, we figure out how many bits we're going to borrow. And if you don't like the term borrow, all right, we're going to steal. Then figure out the binary and decimal value of the subnet mask. And then we're going to apply that subnet mask to the network address to figure out our exact addressing. Okay? All right. Let's take a look at how this would be done by Cisco in a longhand format, what I call a longhand format. And then I'm going to teach you a shortcut that always works and that is going to be your best friend in the exam. But I don't want to cover the shortcut until you see how this would actually work. All right. So, look what happened here. We have an IP address of 192.168.221.37. And what we did was we did a 29-bit mask. How many bits did we borrow? first question. How many bits did we borrow? Go ahead and type it into the Q&A. Think about it. How many bits did we borrow? Great job, everybody. We borrowed 5 bits. Awesome work. That's because the default was 24 bits. So 24 from 29 tells us that we borrowed 5 bits. We went 5 bits deeper with our subnet mask. By the way, if we borrowed 5 bits, how many networks can we create with this subnetting scheme? Well, 2 raised to the 5th is equal to, what is that, folks? 32 from your conversion chart. And by the way, if you weren't here yesterday, you're going to be struggling with some of this. So I know there's some students out there that were not here yesterday. So just keep in mind, you're going to want to review yesterday's session as well. Okay. So 32 networks we can create. Cool. By the way, one more question. How many hosts can be on each one of those networks? Well, we borrowed 5 bits. That leaves 3 bits for host addressing. So 2 raised to the 3 minus 2. That would be what? Someone help me out that's got the conversion chart in front of them? 6. Awesome. So, what can we and this is the stuff you'd have to do in the test. Yeah, if Cisco said to you, you have 192.168.221.37 and a 29-bit subnet mask, the question might be, how many networks can you create? Or the question might be, how many hosts can you have on each of those networks? And you see why these start to become our favorite questions in the exam environment. Because once you know how to do it, it's simple mathematics that always works, and you can very easily get the questions right. That's funny. And Sean says, I had to do this in my work this morning. Yeah, so Sean had to actually implement subnetting in his job this morning and do these calculations. Pretty cool. We'll be doing many examples, Win. Yep, don't worry. All right, here we go. So we just answered a couple of questions based on what they gave us. But now we need to figure out what all of the addresses are that we can work with, right? You need to figure out how the addressing is going to work. So here's what Cisco does in a longhand form, okay? They take the 37, and that's the octet that we're manipulating here, right? And they convert it to binary. Okay. Now I see why they had us convert things into binary. In fact, one of the students in class before class said to me, hey, I can do those binary conversions, but why am I doing them? Well, now we're seeing the why involved with those binary conversions, aren't we? All right, the next thing that we do in the next step here is we go ahead and we write the mask in binary. Okay. So we had a /29, and there is /29, the last octet, in binary, right? It's got 1, 2, let me circle them. It has, or I'll underline them. 1, 2, 3, 4, 5 bits, right? Those are the borrowed bits. So we've got our octet written out in binary. We've got the mask written out in binary. Now we draw a line in between the bits. These 5 bits represent the network information, and these last 3 bits represent the host information. Okay? Now we take those host bits and we copy them in 4 times. Once as all zeros, once as 001, once as 110, and once as 111. The all zeros is our network address. The 001 is the first address in the subnet. The 110 is the last address in the subnet. And as you learned earlier, the all ones is the broadcast address. Wow. So if you convert back into decimal, the first line is the network that we live on. And you can see it done for you right here. It's 192.168.221.32. The next line is the broadcast, or the last line of our calculations, the broadcast. Then we have the first address and the last address. And then we can even figure out what the next subnet is just by adding 1 to that number. Wow. Let's review that again. And boy, oh boy, this would take us forever in the exam environment, right? So we desperately need a shortcut. But what they did to review the longhand method of calculating your subnets is 37 written out in binary, the 4th octet of our IP address, then the mask written out in binary, separate the two, the network portion and the host portion, and then go ahead and calculate all the different combinations of the host portion. And this gives you the network you live on, the broadcast address for your network, and the first and last address in the subnet. And then you could always calculate what the next subnet is. But again, this is very cumbersome, isn't it? I mean, it works, and you really see how the binary works behind subnetting. Yeah, I mean, it's really cool. We can see how the binary math actually works and why subnetting works the way that it does. But boy, oh boy, this would take forever in an exam environment. So let me show you an unbelievable shortcut that works every time. All right, you remember your conversion chart? That's going to be in front of you on your scratch paper. Okay, so here's our conversion chart. One, 2, 3, 4, 8. Whoops, I did it wrong. 4, 8, 16, 32, 64, and 128. Okay. Now, how many bits did we borrow? You told me that we borrowed 5 bits. You go in to the 5th position here, 2 raised to the 5th, and this is the number that your subnets increment on. Yeah, this is the number that your subnets are going to increment on. Oh, wait a minute. Whoa. I started my shortcut wrong. In fact, that's so messy, I want to do it again. Been a while since I taught my shortcut. Let's start over. You are going to love this. Okay, 1, 2, 4, 8, 16, 32, 64, 128. All right, how many bits did we borrow? We borrowed 5 bits. You don't go to the 2 raised to the 5th. I'm sorry. What you do is you go in 5 columns deep. So 1, 2, 3, 4, 5. And this is what a lot of instructors call the magic number. This is how your subnets increment. So your subnets increment from 0 to 7, 8 to 16, 8 to 15, 16 to 23, 24 to 31, 32 to 39. Wow. So look at this. Our address 37 must live on this subnet. And that's exactly where it lives. It lives on the 32 subnet. The last usable address is 38. The broadcast address is 39. And the next subnet starts at 40. Does all of that check out with what we solved for? It sure does. We live on the 32 subnet. The last usable address is 38. The broadcast is 39. And it starts over on the next subnet at 40. This works every time. Let's do some review, and we've got to do another one, obviously, because you want to see that again, I know. How many octets? Daniel, we go as deep. You go as deep as the number of bits borrowed. And that was the part that I actually started to mess up. but we'll do it again. All right. How many octets does a Class A network have in the host field? 1, 2, 3, 4, or 5? How many octets does a Class A network have in the host field? Good. There are 3 octets in the host field in a Class A. Using 6 subnets, 6 subnet bits, how many usable subnets can you create given the use of subnet 0? You can actually ignore this. The exam would not bring this up. The subnet 0 is assumed. They're not even going to ask about that anymore. So just using 6 subnets, how many subnets can you create? What's that formula that I taught you? Great job. It's 2 raised to the 6th. And that is 64. Good job. You are assigned the IP address of 192.168.2.122 and the mask of 255.255.255.240. What's the last usable host address on your subnet? Wow. Now, we could do it the longhand method of Cisco's, and that would be to convert this into binary and to convert that into binary and divide them up and do the binary, or you can use my shortcut. Okay, the first step of my shortcut is, well, actually, let me just give you some time to solve this, because a lot of you are like, let me try it. So let me just give you some time to try it, and then I'll be back in about 2 minutes, and we'll go over my shortcut. let's go ahead and take a look at how we would solve this. First up, how many bits did we borrow? Yeah, we got to figure out how many bits we borrowed in order to use my shortcut. And the only way we can see how many bits we borrowed is right there, the 240. If we did 1 bit, it would be a 128 in that field. If we did 2 bits, it would be a 192 in that field. If we did 3 bits, it would be a 224 in that field. If we did 4 bits, it would be a 240. Does everyone agree that we did 4 bits of borrowing? Does everybody agree? Does everybody see that now? Type in your response. Okay. Everybody sees that we did 4 bits of borrowing. Okay, great. That was the first part, right? Hey, that was tricky. We had to figure out how many bits they borrowed in order to get this question right. Now we know how many bits they borrowed, so we can go into our conversion chart 4 deep. 2 to the 7, 2 to the 6th, 2 to the 5th, 2 to the 4. We're going to go in 4 rows deep because we borrowed 4 bits. What is 2 raised to the 4, everybody? 16. Good job. So guess what? Our subnets increment on 16. So we have 0 to 15, 16 to what would be next? 31, 32 to what would be next? These are our subnets. Would that be 63? What would be next? 64 to what next? Oh, did I do this one wrong? Hold on, did my math get off here? Yeah, 47, you're right. Whoops. It's hard to do when I'm teaching at the same time, right? I can do the math when I'm just trying to quietly do the math. All right, 48 to, help me out, 63. Thank you, Sean. Then over here, 64 to what's next? 79. Then 80 to 95. Thanks for the help, everybody. 96 to 111. And now 112 to, what's the final one? 127. And that is where we live. 122 falls in this subnet. This question is, what's the last usable host address? Well, 127 is the broadcast, so the answer is B, 126. Yeah, don't forget that the 127 is actually the broadcast. Some of you forgot that. This shortcut is amazing, isn't it? This one was a little tricky because we had to do so much addition to get, by 16 to get all the way up to the right increment. Wynn says, what's the 112 again? The 112 is our network address. So 112 is our network address. 127 is our broadcast address. The first usable is 113, and the last usable is 126. Notice this was tricky because it put all those as options in the multiple choice. Wowzer. You probably want to do another one. Okay. Let's do this. Let's take a test that I have up on the Stormwind blog. We'll go under network addressing. And we'll go to this link right here. What is the subnet mask in dotted decimal notation given the IP address and prefix length of 172.16.55.87.27? Go ahead and type in your response. What's the subnet mask in dotted decimal notation given the IP address and prefix length of 172.16.55.87/27? Good job. Good job, everybody. What do? Well, we just look at that /27 and we figure out how many bits we borrowed. So you say /27, whoops. Let me start over. /27, its default is a 24, so 27 minus 24 is 3. We borrowed 3 bits. The subnet mask would be 128 plus 64 plus 32 in dotted decimal. So the subnet mask is 224. So it's 255.255.255.224. That's what the exam engine expects to be typed in. And remember, this quiz is located in the CCENT Network Addressing Expert blog for those of you that will want to run through it at a later time. We'll just submit it blank. How many subnets can you create if you borrow 5 bits for subnetting? The use of subnet 0 is permitted. How many subnets can you create if you borrow 5 bits for subnetting? Oh my goodness, is this easy? This is 2 raised to the 5th power, and 2 raised to the 5th power is what? From your conversion chart, it's 32. Great job. how many total bits long is the prefix length given a subnet mask of 255, 255, 255, 252? Two 255.255.255.252. How many total bits long? Be careful. 8 bits here, 8 bits here, 8 bits here, 6 bits here. 8 plus 8 is 16, plus 8 is 24. The correct answer, /30. So be very careful when you're in an exam environment to read carefully. How many total bits long is the prefix given the following subnet mask? Enter the complete default subnet mask in dotted decimal notation for a Class B address. Easy. 255, 25500. Yeah, everybody's all over it. Good job. Given the address 172.16.258/28, how many usable host addresses are there? How many usable host addresses are there? Well, this should be pretty easy, shouldn't it? How many usable host addresses? It was a /28. So 32 minus 28 is how many bits we have left for subnet for host addressing, and it's 4. 2 raised to the 4 minus 2 is equal to 14. Great work. So you can see a big part of this is reading carefully. That's the biggest part of this. What exactly is the question asking? Given the IP address and mask of 192.168.221.37, 255, 255, 255, 248, what is the network address in dotted decimal? 248 and 37. All right? That's really the only piece of information on there that's relevant to us. So the .37 and then the 248, the .248. So how much subnetting did we do? If we took 1 bit, it would be 128. If we took 2 bits, it would be 192. If we took 3 bits, it would be 224. If we took 4 bits, it would be 240. If we took 5 bits, it would be 248. We go in 5 deep. 2 to the 7, 2 to the 6, 2 to the 5, 2 to the 4, 2 to the 3. What is 2 to the 3? It's 8. So our subnets increment on 8, 0 to 7, 8 to 15, 16 to 23, 24 to 31, 32 to 39, 40 to 47, 37 lives right here. So the address would be .32 of the network. The first usable would be 33. The last usable would be 38. The broadcast would be 39. And the next network would be 40. This is how unbelievably easy these are. You just got to embrace this process. And for many of you, this is going to involve watching these videos a bunch of times. And also working with the mentors that have suffered through subnetting and are standing by ready to help you. By the way, in the real world, we use a Subnet Calculator to solve this stuff for us automatically. And we can't use this in the exam, but it could be a valuable check for you, right? To make sure you're right. For instance, on that one, it was something like 192.168.137. And they gave us a mask of 248. So we can check our work against this calculator. Look at this. Yeah, we can check our work against this calculator. It says, here is your host range. Here's your subnet ID. Oh, it wasn't 137, it was 37. You get the idea. We can check our math against the subnet calculator. It's just that we don't have the subnet calculator in the exam. And here's everything we discovered. 33 to 38 is the host range. The subnet ID is 32. The broadcast is 39. Yeah, this is really cool. It shows us how many hosts per subnet. So this is a nice IP subnet calculator, one of many free IP subnet calculators that are available.